start over. Who's the track coach?
Landers.
Miss Martin. I think Landers quit.
He did?
Well, yeah, because you had to take care of the baby or something. You guys remember all this, right? All right.
We heard something with log.
Yeah, that's true. Okay, so how do we get from square root of 2 to 2 to multiplying by square root of 2? We call that the common ratio. Square root of 2. And then we need to know how many terms we were adding together. You guys remember how we found that?
Log square root of 2, 64 equals n.
Yeah, so it's square root of 2 multiply how many times until we get to 64. That will tell us how many terms there are. And yeah, we turned it into a log base ACB, remember? Equals x, and we plug that in, and we got 12, I believe. Okay, so there's 12 terms, common ratio is square root of 2, and the formula is on 488. Geometric series to add the first n terms together. Okay, so the t sub 1, the first term is square root of 2. 1 minus the common ratio, square root of 2, to the, how many terms are we doing? 12. All over 1 minus square root of 2. One of those problems where they give us the answer or not. Yes, they did. Silly. All right. Now, there's my work. So, we'll just say that equals, they didn't even simplify the denominator. Oh, must have been a negative on top, so they distributed it to the bottom. Okay. I guess we're skipping 15. 17. Find a formula for t sub n, the nth term of the series. That does then give a. Okay. And give a recursive definition for the sum. So, let's see, number 17, 2, 4, 6, all right. Okay, so what they want us to do is kind of, like, I guess think about it as more of a sequence, like we did a couple weeks ago. Like, where are these numbers coming from? Well, yeah, like, first term is 2, the second term is 4, the third term is 6. So it's just the number of the term times 2. So it's 2 times n. That's the first thing they wanted. And let's see, what's the second thing they wanted? The sum as a recursive. So for the recursive thing, you have to define it based on the last term. So You always use that little n minus one thing. So yeah, it's just going up by twos. So the recursive is probably easier. It's just the last term plus two. So they wanted both of these answers. Oh, no, that's not right. That's wrong, my bad. That would be the recursive definition, but that's not the sum. My bad. Yeah, okay, let me try that again. S sub n equals S sub n minus 1. So the sum, it's not going to be just 2, 4, and 6. The sum is 2 for the first term. It's actually 2 plus 4, 6 for the second term. So we're not just adding 2, we're adding 2n. Okay, and if I'd have to back up one step to get my first term. So what would come before 2? 0. So that's okay. Now we got it. I might help you guys with the evens on this one. Except for saying no. All right. What is the pattern on number 19? 8, 12, 18, 27. Anybody see it? It's not an adding pattern. It's a multiplying pattern. So, yeah. Well, I looked at adding first. It was like plus 4 and plus 6 and plus 9. That's not really a pattern there. So then I looked at multiply. You guys know how to what multiply is? 8 times what equals 12?
1 point something.
1.5, because half of 8 is 4, so it's like you're adding half of. So it's multiplying by, and it works on these also. It's times 1.5. Okay, so how do we get 8, 12, 18, 27? I guess we'd have to back up a little bit. So we'd have to, what comes before 8?
6.
8 divided by 1.5, that's going to be a mess. Let's see. It's a weird decimal. Oh, they just put an n minus 1 on it. Okay, that would work too. Okay, so if we start with 8, and we're going to multiply by 1.5, but the first term we don't really want to multiply by 1.5 yet to get 8. So what they did is they just put n minus 1 here. Because on the first term, when you put a 1 right there, that makes this a 0. That kind of eliminates the multiplier. So on your first term, this will just come out as 8. And on the second term, when you plug a 2 in there, 2 minus 1 is 1.5. Then it will multiply to get that outward. Yeah, I was thinking more like we did in the past, where we just divided by 1.5 to figure out what would be here, and then just start multiplying by 1.5. Which would work. It just comes out messy. So I used the book's trick. All right. The sum. Well, we're going to kind of use this thing. So we need to define the first term. Well, did they do S sub 1? I don't even know. Yeah, okay. Okay, so they just said first, the 0 term is 0. All right. sum of the zero. I don't know, that doesn't make sense. Okay, so gonna start by adding 8 plus 8 times 1.5 to the n minus 1. Does that work every time? Yeah. Okay, so I just put the first term right there. No, that's not gonna do it. 2. Yes, it will do it. So it'd be 8 plus 12, 2. Oh, I have to use s to the minus 1. Okay. Alright, my bad, I forgot what I was doing. Okay, so on the first term we want to add 8, which means we want this to be nothing. Yeah, it's hard. I forgot I was doing it recursively. That's what I did wrong. So anyways, on the first term, s sub n minus 1 is just 0. So we want to add 8, which means we want this to kind of be nothing. When we plug a 1 right there, 1 minus 1 is 0, so I just kind of get through with that. So basically we're just using this to find a recursive. Just use the last term plus that stuff, should do it. Alright, let me help you guys on 18. Let's look at these two. 1, 3, 9, 27, you guys see the pattern on that one?
I'll multiply by 3.
Oops, every time. Okay, there you are. Yeah, it's multiply by 3. Alright, so we want the first term to be 0. So how do I get, we want the first term to be a 1. So how do I get a 1 out of this?
Do you put it as an exponent?
Well, I need my exponent to be a what? 3 to the what equals 1?
0.
0. 3 to the what equals 3?
1.
1. 3 to the what equals
2.
Right. So I need this first term, I need the power to be 0. The second term, I need the power to be 1. The third term, I need the power to be 2. But on the first term, n is worth 1. On the second term, n is worth 2. So I need to use kind of that trick last time where I just put n minus 1. Alright, and then, they always start out with this, don't they? S of 0 equals 0. So S of 1, S of n equals, if it's recursive, what always goes right here? N minus 1, based on the last term. Okay, what are we adding to that? Yeah. That's how you do it. I'm gonna let you guys struggle with 20. Yeah. Okay, what's the pattern on 20?
Minus 3.
I always put the commas. Any ideas?
Minus 3.
That's not right. I was just trying to point it out. How do we get 50? And then how do we get 47? And how do we get 44? I keep putting commas.
Is it like a multiply then
Minus
minus?
3n.
Okay, 50 minus 3n. Let's see if that works.
So it would be like n minus 1 or something like that.
Okay, yeah, if we put a 1 in here, we want it to be 50. So if I plug a 1 in here, 50 minus 3 times 1 is 47. That gives us that term. So how do I fix
Minus 1. 3n minus 1.
like that?
Because then if you put a 1 in, then it'll just be 3 times 1.
Or that'd be the recursive definition.
Okay, you guys are close. It's not quite right. If I plug a 1 in right now, I get 50 minus 3 minus 1 is 46.
I mean the little one.
No.
Would be exponent.
No. Okay, for the first term, we want to subtract nothing from 50. Okay, in the past, I've had you guys write like 53, and then we did minus 3, and that would actually have worked. Not sure why they're not using that method on this one, but that would have worked. You could have done it this way. If you want to subtract nothing, when you put parentheses around that. When you plug in a 1, 1 minus 1 is 0. So the first term will be subtracting 0. Okay, so anyway, that would do it too. We probably should have just kept doing it, even though the book changed a little bit. Maybe we should have just kept doing it the old way. We back up one step and just go like that. Probably less confusing. All right, so the sum of the first n terms equals the sum of the previous terms plus that stuff. We wouldn't really need parentheses here, but all right, try the evens. You guys remember how we did those yesterday?
Yeah, the
Okay,
only-
there's a formula on top of 487 to help you with number 2. 2 through 8. And then once you get to 10, it's geometric, so you have to switch formulas to the other one. Why don't you guys try number 2? I'll come around and see if you figure it out.